Good morning, everybody. Welcome to another exciting edition of Move Monday here at fairly overcast Palo Alto. It's no longer quite as hot, but it is very great. I hope everyone had a great week and a great weekend. I know I certainly did. I did nothing, and it was fantastic. Hello. Before we get started with intros, I'd like to make my weekly request, and that is if you are looking for a career, if your mother's looking for a career, or her girlfriend or her girlfriend's boyfriend, if any of them are looking for a new career, we are hiring across a wide variety of positions here at Aptos Labs, business development, engineering, design, etc. AptosLabs.com/careers is the best place to go and find and see what's still available. AptosLabs.com/careers. Begin your journey with Aptos Labs. Whew. The weekly pitch. Well, we have quite a packed day today, but before we get to that, I think we can go around and introduce ourselves for all the first-time viewers. And they're here joining us in person this week, actually, is Wolfgang.
Hello. David, software engineering.
Hi, Avery, CTO.
Daniel, engineer of sorts. A sorted engineer.
Master of taps.
Probably the faucet man.
Yeah, king of faucets, allegedly.
Yeah. Or is it the monkey of faucets now?
Yeah, something like that.
Hi, I'm Sherry. I yell at people.
And I'm your host, Max.
Who's got a very amazing thing. It's Max's birthday today, so we all just
Thank you. I was born today, many moons ago.
And just to be clear, not that I'm gonna prop Max up too much, but if you do have really cool NFTs of various creatures that might look like Max, he would be very happy to see those PFPs.
I do love a good PFP. He does not lie. Thank you, everybody. Yeah, we have quite a packed day today, starting with a tweet and a new faucet. Faucet?
Yeah, so we've been doing some stuff with our faucets lately, specifically for testnet. As you have probably noticed, we have a new testnet faucet flow integrated with the community platform. So you can go there and get all of your testnet funds for all of your testnet minting and getting your monkeys and your alpacas and all of that kind of stuff on testnet. The reason we did this is because the previous testnet faucet was very popular, and many people were getting starved out of the funds that they needed. So we decided to put it in community platform, have some extra requirements, captures and whatnot, and now everyone should be able to get their share of testnet funds.
Yeah, I heard there was a really funny rumor that anyone who got faucet in testnet would also get a faucet at mainnet. That rumor is not true.
That's right.
No!
That rumor is insane.
Yeah, don't stop hoarding testnet coins. They are not going to be valuable for mainnet. They're really just test coins. And please allow each other to get faucet coins so that we all can be testing mainnet or mainnet, or get ready for mainnet.
And to say what she really wants to say, if you keep hoarding the testnet coins, we'll send Sherry to yell at you.
Yes, we will find you.
But to kind of roll back in, if you tell us a little bit about some of the goals that we have for the faucet distribution, that type of aspect, so people can actually be cognizant of how to use the faucet effectively. Because I know maybe the logging is a little bit ambiguous right now.
Could you elaborate on what you want to hear?
So what is the experience? Like, how many times can a user get an IP address, account address, or daily limits, those type of aspects?
Right. So, and then get yourself an account with some funds in it. And then we currently have limits on, again, trying to make sure everyone can get their fair share. So current limits for testnet faucet, about will be 5 requests per day per IP address. So, and in order to do this, you need to get into the community platform with a social login, complete a captcha in order to get these testnet funds. So each fund from the faucet will be, we're still sort of working this out actually. I guess 1 APT per request.
Leaning towards that.
So something around like that. So you'll be able to get roughly 5 APT per request, which should be more than enough to do any kind of module publishing and testing any dApps that you've got, minting some NFTs, which usually run for 0.01 app these days on testnet. So that should be plenty.
So the one thing I want to call out is, interesting enough, there's been some load tests on testnet recently that, well, is really amazing because the network withstands a load test. The fee market actually works. We did several tests on top of these very interesting load tests to validate that, hey, our network is really production ready. The one thing I want to call out there, though, is testnet was never really meant for load testing. And it's really meant for people to be able to explore and try out Aptos for the first time. And we have been very generous with how many funds that we've actually given out there. In fact, I would argue testnet has the worst inflation of any existing economy to date. Even, certain countries probably are better with their economics than our testnet. Please don't abuse testnet. If you continue to abuse a testnet, we will have to rethink the tokenomics of testnet, and that will honestly be unfortunate for everybody else. And we want to keep it open. We want to keep it free. We want to keep it flexible. So, if you do have tests you need to run, feel free to reach out to us. We're more than happy to talk to you about ways to effectively evaluate whatever configuration or framework or whatever, what have you not. But be mindful of that, and that's why we're really kind of locking things up with the testnet faucet so that we really enable a utopia of testnet. Like I know in other testnet environments, you actually may have to pay for coins, which is absolutely insane in my opinion. Like the whole purpose of Aptos is to enable everybody to have access to the network. And so abuses of this nature are actually limiting the ability for this to be really for a layer one for everyone. Huge props to Daniel for actually bringing all these technologies on board that does actually help for the better distribution of testnet coins to everybody in the ecosystem.
And for Max and Zach for putting together that beautiful front end.
And on that note, the other one I want to call out there is we don't have a very clear policy of how wallets get integrated with the community platform. I don't know, Max, if you want to be put on the spot. Well, I put you on the spot anyway, but if you have anything to say at this point in time, or if that's something we're still kind of working on.
That is still something we're working on.
Okay. Great response.
Yeah. Now we like to have, obviously every wallet integrated as possible. And I think that there's a very clear kind of path that we've set up for doing the integration. It really is just a matter of being able to keep certain pieces like the adapter open source to make integration easily while keeping the rest of it kind of closed source. And so that's something that we'll definitely be working towards. But if you do have a wallet that's not integrated and you would like to be integrated, we definitely would love to work with you. There's really only a couple of things that we do need to know to kind of get that flow working, and we can help work together and test it out or manually in the meantime before we can get a nice GitHub flow for that ready. So if you do want to integrate, let us know. Yeah, and stop hoarding testnet coins, please. Or send them all to me.
There's no translation to that to mainnet.
No.
Just to be clear.
And this isn't a trick. We're not tricking you.
Yeah.
No. I think CTAL got
And
millions
maybe
of
there
them,
should
so.
be other way around. Like whoever we find out is hoarding testnet coins, punished over mainnet.
If only that were possible, though. Just to be clear, we have no power over mainnet.
Yes, we cannot halt our chain.
Anyway, so shall we move to our first guest?
Yes, our first guest, Al Noki, here from Econia, to talk to us about gas and his latest insights on the new gas schedule.
First, Avery is going to share a couple.
Yeah, good to see you, Al Noki, but I just want to get a couple points in beforehand, which really relate to the upcoming, tokenomics paper that we've been promising soon. It is coming soon, but I think the point is that we would definitely want to at least talk through some of the principles we have with respect to gas in that space before we get into it. So first thing, I think, obviously the network has real costs to run. Validator operators have been generous in terms of being able to find the right hardware, with CPU, memory, SSDs, great networking equipment. And those are the costs that are kind of relate very heavily to gas pricing. Those costs of operating Validator will change over time. So new technologies are coming out. We're moving from, into 5 nanometer process technologies for CPUs. We're seeing NVRAM become more affordable and all kinds of things like that. And so that model changes over time. The third thing I think worth mentioning is that our goal as software engineers is to build the most efficient use of those resources as possible, consuming the fewest amount of CPU for the most amount of instructions, making sure also anything we do for safety checks are going to be extremely cheap. We want to encourage really good programming practices and paradigms, as opposed to producing things that, for instance, are non-atomic and non-recoverable. And this is something that, given those kind of factors, is going to really change a lot over time. Gas is a mechanism that's designed to prevent denial of service attacks on these fixed set of resources in the network. And again, given all the constraints changing during various periods, even things like network going down or network cables being cut, we have to be able to adjust gas dynamically. And therefore, we built in a really cool feature where on-chain governance can actually control the gas schedule and control the gas functionality and dimensionality over time. So we can evolve to the kind of changes in economics, the changes in the hardware space, the changes in validator operations. And so we expect that this is a very evolutionary process that will take place over the coming years. Therefore, anything we do in kind of early days, especially is taking into account the fact that we really want to see a lot of growth in the network. We want to encourage people to run transactions and experiment and play and be creative with their applications with this network that were not easily possible in other networks in the past. And so we expect our pricing to be on the lower side. At the same time, we also need to defend the network. So in case we see attacks to try to fill up the disk or help us run rapid over our memory usage or things like that, we will institute governance processes where the community can vote on and have these things fixed up very quickly in a short period of time. And with that context, I would love, we of course encouraging community to participate in these discussions. And I think Al Noki, we really appreciate his opinion in this space as one of the early adopters in terms of optimizing gas schedules for his particular application. So with that, I think we'd love to bring Al Noki on and hear.
Thank you for that intro. And yeah, so the team at Aptos has been making this web scale gas schedule that, like Avery said, prevents denial of service attacks, makes it so that operators can make the most out of the resources they have on chain, so that dApps can move around the most data, modify the most state in a way that doesn't, blow things up on the operator side, on the validator side. And so at Econia Labs, we have been sort of taking a deep dive into the gas schedule lately because it informs a lot of our own sort of design principles. And at a high level, there are, 2 or 3 kind of major components of this. There's instruction gas and there is storage gas. And by far, storage gas has the largest impact. And we wanted to take, the last week or so, this opportunity to help the community understand and in our own efforts in doing our own research and how to optimize around the Aptos' gas schedule. We did a PR and we added an article page to the Aptos documentation called How Base Gas Works. And I would like to share my screen and maybe just give the community a little walkthrough of that. 1 second. Got to do the security and privacy to allow Zoom to take over the screen for a second. We'll do that later, actually. So I'll just talk a little bit about more because I don't want to quit and reopen Zoom. But the main takeaways are that on aptos.dev, there's this new docs page called How Base Gas Works, and it breaks things down into 3 kind of major sections. There's instructions, storage, and payload. And instruction gas, you have things like conditional branching, you have popping off the stack, immutably borrow, and all these different operations have their own price associated with it. And the Aptos team has incentivized good programming practices, for example, like asserts and events that make it easier for like logging and debugging kinds of things. And so there are different schedules for different things like, your sort of function calls and the sort of base level move functionality. But then there's also things for Aptos framework, things like the table, right? And a lot of the encryption functions, I'll note, are actually pretty expensive just because there's a lot of computation that goes into those. So just be aware of those. You can look through the Aptos gas schedule. And in this docs page, we provide plenty of references to the different source files and how they're implemented. But one thing that I'll note definitely is that storage gas has by far the largest influence on how costs are going to apply to a program. And this is because storage on chain is forever. And so if storage gas was free and everyone could open up 10K of memory with no cost, people would be doing that. And then the chain would blow exponentially, and there wouldn't really be any kind of way to deter this sort of tragedy of the commons behavior. And so there are 3 kind of major sort of operations that can happen in storage, and then they can be applied on a per item or a per byte basis. And so per item is kind of the more important one because this means that you have a special slot in memory that you're grabbing for yourself. And so there's only a limited amount, and this can obviously change over time, but things are constructed so that it is by far the most expensive to create a new slot. So this is basically just the equivalent of allocating memory. If you open up a new address, you are incurring the highest costs, and that's called a per item create. And so within each create, you have to pay for each byte that you consume. And then also you have per item reads and per item write costs. And so creates are by far the most. And then anytime you read from storage or you write to storage, you also have a cost. And again, these are associated with the amount of bytes involved in the operation. And so there's some math on the docs website that talks a little bit more about the relative amounts between these two and some of the implications with what this means in as far as design principles go. And for optimizing gas at the DApp level, as well as ensuring system performance on the whole L1 level, there are a couple sort of core principles that people can keep in mind that can help them to design the most efficient programs. And that is minimizing per item creations is the first one. And this means at any time you do a move to operation that creates a new resource or you add something to a table, you are allocating a new region in memory. And in the back end, this gets added to a Merkle tree and there's some sort of authentication that goes into it. But the important part is it's kind of like you just bought a new area on a hard drive. And so you have to pay for that area on the hard drive and you have to pay for how much you put into that little area. And so the important part is to minimize per item creations as much as possible. And this means that you should track unused items and overwrite them rather than creating new items when possible. And so in practice, this has an interesting implication, and namely, it's almost like garbage collection on the DApp level. So rather than adding a bunch of entries to a table and then deleting them when they're done with them, one more useful, a more practical strategy is to assign an ID to every entry in the table and then keep a stack of unused entries and then rewrite them later, because rather than allocating and destroying, you're allocating once and then you're reusing. So it's, reduce, reuse, recycle in a sense. And so if you can track unused items and overwrite them and create new items when possible, that's principle 2 that we've kind of outlined. And you want to contain per item writes to as few items as possible, because you have to pay for every item that you write to, and you have to pay for all the bytes that you write to. And so always read rather than write if you can, and then minimize the number of bytes in an operation, especially writes and creates. So some implications in practice are, for example, that if anyone is familiar with writing like assembly code or anything on a firmware level, there's a lot of bit packing that you can do to keep your cost down, right? Like a Boolean, for example, takes up a byte, but if you're going to be storing 8 Booleans, you can bit pack them all into 1 byte, and then you've cut down your cost by 8x. And similar, you can store different fields in one U128, for example. That's what we're doing in our binary search tree. And I think that might be a good place to kind of finish this off, is to just talk a little bit more about binary search trees, because that is going to be, an important element for a lot of the more complex projects that are trying to manage, sorted data, for example. And in the beginning, with an earlier version of the gas schedule, at least Econia sort of began with this vector-based binary search tree. And vectors are each treated as a single item. And so, for example, if the vector is going to be small, it makes sense to just keep a few items in it, and then you pay less than if you were to use a table, because in this case, the vector is treated as a single item instead of each entry in the table treated as a couple items. But if you store a lot of things in the vector, it actually becomes even more expensive than a table, because the per byte cost dominates. So it really does depend on this sort of threshold of how many bytes do you have versus how many items do you have. And so then, Econia sort of evolved to a different implementation of a tree, which was a table-based implementation. And earlier on, there were different relative values between reads and writes. And so this sort of incentivized a tree known as a crit bit tree that doesn't do self-rebalancing behavior, but it doesn't necessarily have to write to more things when it does rebalance. And with some recent reshuffling now with the finalized schedule, we've sort of settled on the traditional AVL tree. And this is because if you're going to be, writing to global state, right now it costs about the same as a read, as long as you keep the bytes low. And so in the end, the result is that you're likely going to want a self-rebalancing tree that has everything bit packed at each internode, because you're keeping bytes to the lowest amount, and you're also keeping item operations to the lowest amount, because you have the lowest height in the tree to traverse. So that's just like one kind of representative sample of how the gas schedule informs data structures in practice. But it is important to keep in mind for anyone who wants to build anything like a linked list or a binary search tree or a tree or whatever, that the gas schedule has real implications on your program costs, and users are going to pay more if you don't keep these principles in mind. And ultimately, the chain is going to have less resources for everyone to share. if you don't keep these principles in mind, of course, but there will still be a penalty, which is reflected in the gas costs. And so, we put out a little post about this, and we obviously have that article that we have on the Aptos gas page on the docs website. And I'll just take that opportunity to encourage other community members too. If there's something in the documentation that you're figuring out for yourself that you need to reverse engineer from source code or something, or there's some more clarity you can provide, like please just reach out to Aptos. Driven project, and it helps us to be able to contribute to these things, because now we have this official reference that we can use when we're designing around, and we want to provide that to the community. So we would just encourage other people to do the same and let us know what you find out about how to keep your gas costs low and moving forward. So I think I'll hand it back to the folks at Aptos Labs, but thanks for the opportunity to talk here today. We appreciate being involved in the the early design of this system and being able to optimize everything down at the bit level and make sure that we can keep our costs low. So thank you.
Amazing. No, thank you so much. And thank you for the call out that, we are always looking for anything you discover, any questions that you have that you found answers to, that you're probably not the only one who has those same questions. And so we would absolutely love contributions for documentation, source comments, really anything. We love to see it, and we love to help make it possible. So thank you so much.
Just want to call out, props out to Major Lift. If the testnet faucet gets cut off again because of the hoarders, it'll be like Tom Hanks losing Wilson in what was that movie?
Castaway?
Castaway, yes. We don't want to lose Wilson.
We don't want to lose Wilson.
All right. Anyway, let's move on to Robert Chen from OtterSec.
Yeah. Welcome, Robert. I think you are on mute. There you go.
Hey guys, how's it going?
Hey, how you doing?
Pretty good, pretty good. How are you?
Good. Welcome. Robert here from OtterSec has come to talk about auditing Move primitives and helping make and keep Move safe.
Yeah, thanks for having me on.
Yeah, would you like to start with a quick intro of yourself, and then we can bounce around some questions, or if you want to just give an overview of what OtterSec's up to in the Move space? I think lots of different opportunities to proceed.
Yeah, so I'm the founder of OtterSec. We do smart contract auditing both for Aptos and also for a lot of projects building on Aptos. And we're really interested in Move because it's I think fundamentally different programming paradigm, right? It allows you to construct programs which are often safer by default, and at least for the smart contracts that we've seen using Move, they tend to be safer and more well written. But I think a large part of that is also working with the Aptos team to kind of secure these fundamental building blocks, right? So Move as a language might be secure, but we also want to make sure that the Aptos framework and also the Move VM are secure. And that's kind of where we've been focusing a lot of our efforts lately.
Awesome. So what is your approach, I guess, the overall approach kind of been like? What are some of the things that you've dug into, looked into throughout the process?
Yes, I think one of our core beliefs as security people is, I think in order to effectively audit anything, you need to have a very strong understanding of what is actually happening at the lower levels. So you need to know exactly like what the Move VM is doing, how it operates, just so you can figure out if there's any edge cases that potentially like the protocol developers have missed. So I guess one thing that we're looking at is how do we make the Move VM more fundamentally secure? And that's part of our work with David and Wolfgang, and that's been really exciting so far. And some of that is both adding mitigations to the Move VM, but also exploring different ways that we can potentially attack the VM to try to get it to break down in anticipation of our mainnet. So ideally, we are the ones that find the vulnerabilities as opposed to it being found day one on mainnet. So that's been a pretty exciting journey so far. I guess kind of the second area we've been looking at a lot is actually the Aptos core framework. So oftentimes when developers build on Aptos, they interface with the Aptos framework, which is a set of Move modules that are deployed at the system address that are written by Aptos core developers. And most of the time these modules are fine, but sometimes there's a few edge cases that we want to come in and then work with the Aptos team to resolve. We want to make the framework as safe as possible for people to use. So that's kind of another area of interest that we're looking at. And then I guess like the final area would of course be applications building on top of the framework. So we work with a couple big ecosystem partners here as well. So
Amazing.
So, I mean, the first question that comes to my mind, Robert, is, taking many steps back, how did you even find Move in the first place? Because I imagine OtterSec was originally founded for other smart contracting platforms and frameworks. So how did you stumble into this space?
yeah, so actually this is a funny story. I was getting it was in Texas. I was getting barbecue with some friends, and then one of my friends showed me like this new smart contract language on his phone. He's like, "Hey, you should check this out. This is like a really cool language. I think it's going to be the future." Right. So actually, originally we started out on Solana. So we did a lot of Solana, so a lot of Rust-based audits. And then I took a look at Move, and then I thought, hey, this looks a lot like Rust, right? It has many semantic similarities. There's borrowing, references. It's of course Move is a bit higher level than Rust, but it still feels very Rust-like, at least at first glance. And then I kind of dug a little bit deeper, and then I realized that Move seems to avoid a lot of the issues that we saw on other chains, right? So I mean, I think this is not to like shit on other chains, but for example, one of the main issues that we see on Solana is that account checks are really hard, and this is something that we're trying to fix for them. But also, I think Move as a language just makes it safer by default, right? Like you don't have this issue of account checks because there's no notion of account built into Move. Everything is a higher level resource, and once I saw that, I was really excited. I was like, hey, I think this is potentially going to be the future of smart contract languages, or I guess just in general, I believe that structurally safer smart contract languages are going to be the future. And I think Move is a pretty good example of one of those languages.
Very cool, very cool. So now that you're here and you're working in the space, I'm kind of curious if you could just walk us through your process or OtterSec's process in really trying to harden both a language, a VM, as well as the frameworks and that type of stuff. Like walk me through like the end-to-end process. Because there's so many different ways to really think about ways in which you can attack it and where the prioritization lies. So I mean, now how are you prioritizing effectively so that we can really secure both Move and Aptos effectively?
Yeah, I guess the way I think about it, or I think the way we think about it is trying to eliminate vulnerability classes as a whole, right? So I think when you have a very complex target, there's going to be, many different bug reports. But I feel like the thing that you should learn from the bug reports is kind of what broad categories they fall in, and then design mitigations so that you will never have to deal with, or so that you can provably never have to deal with that vulnerability class again, right? So I guess one example potentially with the Move VM might be like, for example, ensuring better type validation, right? And then if you have that built into the VM, you can be, well, with like some more formalization, you can be pretty confident that you will never have to deal with a type issue again. And then I guess another example might be like the depth of type generics, right? So for example, if you have like gas denial of service issues due to really large signature tokens, if you like limit the size of those, you can be relatively confident that you will never have to deal with that again. And of course, never is a very strong word. And I guess like for the signature token mitigation, it's not a guarantee, but it's I think by like trying to block out these swaths of vulnerabilities at once, it's much more effective. And I guess another example of that, like more higher level, is if you look at the framework and then trying to make recommendations where the framework is more intuitive or easier to use by default, right? So, maybe modifying framework functions so they abort early if there's incorrect parameters being passed to them, or something like that to make it easier for people to build on them. And again, like eliminating vulnerability classes.
Very cool, very cool.
I have a question.
Go for
I mean, given your experience with Move at this point, do you have any thoughts about how we can even make it more safer and secure?
Yeah, I think Move as a language is already pretty secure. I think right now I see like most of the complexity is probably in the framework code and the virtual machine itself, right? So I think most programs that we actually see on Move are pretty safe. I would say there's very little anti-patterns that we see, or I mean, there's like a couple. Yeah, there's like one or two minor denial of service patterns that we see, but there's no critical security issues that we see repeat themselves across programs. And I think that's a really good sign for the language, right? That means that the language is written in a way such that people aren't making these same dumb mistakes again and again. But I think right now, kind of the focus for us at least is how do we make sure that the language actually lives up to its expectations? And how do we make sure that Move as a language, both as like a theoretical concept, but also in a production environment is able to deliver what it's promised? And that's kind of what we've been working on, these past few weeks.
Well, now you've got me really excited, Robert, that you mentioned anti-patterns. Could you actually share what those anti-patterns that you found are and ways in which developers can actually work around them to get the desired outcomes?
Yeah. So actually, this one's kind of interesting. If you do coin, so this is like a denial of service issue that we've seen pop up pretty often. If you try to do coin and you try to register a Aptos coin for an arbitrary account, someone else might be able to come in and register that coin before you, which would cause the register coin operation to fail. So oftentimes we'll see people accidentally put the register coin in their initialize function, or they'll put it in some, creation function, but they're not really thinking about the annoying case where someone else comes in and then creates the account before you, right? It's not like a huge issue. It's more an annoyance. You'd have to redeploy the program. The way to fix it is to check if the account, if the Aptos coin account existed before, and then if it did, just skip that step, right? So it's not like a huge issue, but it is something that we've kind of seen pop up again. And I think the root cause of this is people don't really realize, or they don't really think about, one, the fact that you can register a coin for anyone, register an Aptos coin specifically for anyone. Like generally you cannot register arbitrary coins, but Aptos coin you can. And then two, they don't really think about the fact that, coin registration can abort if it's already happened by someone else. So that's kind of like one of the big foot guns we've seen, but it's not like a critical security issue. I'd call it more like a medium on other, or lower medium, it's like an annoyance.
So I guess on that note, there also seems like there's an opportunity here for, if we are seeing frequent anti-patterns in developer code, to actually take that as an opportunity to enhance the framework to, either expose APIs that say, try register coin or something like that, so that if it doesn't, it just returns back a Boolean rather than doing an assert that why are you trying to register a coin twice?
Yeah, I think that's a really good idea.
What do you think about we could potentially improve the framework to help with these developers?
Yeah, I think like try register coin, or maybe specifically for Aptos coin, right? So I think for most coin registrations, you probably, so I guess this kind of this trade-off, right? Like you want to avoid as much silent behavior as possible. So, if a coin registration fails, maybe the developer should be notified about it, right? And then the argument could be like, maybe there should be a hardware abort, so they have to forcibly reason about it. But I would say for Aptos coin, maybe, right, it's like such a fundamental coin, and the fact that anyone can register it might mean that you would be okay with like a try register Aptos coin method, which would, attempt it, and then if it already exists, it would just silently fail. So I think, framework methods like that are a really great way to kind of deal with these anti-patterns, and yeah, maybe we should add that one in.
So slightly unscripted, but maybe I'll let somebody else go first before I go with my unscripted question.
Actually, I'll just continue along this line. So I'm just thinking about how C++ and Java became extremely popular in part due to the fact that there were pattern books being printed out about the best practices for how to use these languages. Do you feel like that might be something very valuable for Move, or do you feel like it's too early for us to kind of identify those best practices for programming yet?
Yeah, that's a really good question. I guess I have like two kind of competing arguments here, or two competing thoughts. One, I think having examples is really good, right? So I feel like, some people have already open sourced their projects. I think the more people open source their projects, the more examples you have, and the easier it is for new people to write programs. But at the same time, I also acknowledge the fact that with any new language, you tend to not fully understand what the foot guns are until you get, until you've actually programmed it, right? So it's hard to say at this point. I mean, like right now, we don't see that many foot guns. That's not to say, 1 year down the line, we're not going to see, tons of foot guns. But at least for now, I mean, it seems that having maybe like some recommendations for example programs, I think there already are like a decent amount of example programs, but maybe I guess more complex programs, right? Like maybe how do you format your files? How do you structure your modules, right? Like how do you, like for example, should you have utility math functions in a separate module? Like kind of lower level design choices like that, I think might be good to explicate, just so newer people have somewhere to start off from.
Yeah, so my question was actually on the coin register. And so you can imagine for central exchanges, and this is something that didn't really dawn on us earlier on, and now it's coming to be a fun topic. So if I go to a central exchange and I want to buy another coin that's on top of Aptos, but I don't have it registered in my wallet, there's no way for for me to go buy from the central exchange and then just deposit to my account because I've never called register coin. And so if this being completely on the spot, if there's any way in which you would kind of think about how we might go about doing that inside the Aptos framework.
Yeah, so actually, I mean, I think the way you'd probably do this is with like on Solana, they call this the associated token account, but you essentially have another program that creates a token account, like creates a resource account and then signs for it and then associates it uniquely with a tokens, address, right? So you can create a wallet for any address. And actually, I think someone has already did this. I believe it's called Xcoin. So yeah, I think it already exists. It's like a pretty simple program, probably like 100 lines or something. And then essentially allows you to create, a token account for any address. And then if they want to claim those tokens, they're able to, then call the program and then claim them. But otherwise, they can just leave them there if they want.
Yeah, that's actually a pretty powerful primitive there, because then you basically would allow authorization from one account to go and claim anything that's in there, but also it still can be managed by the central exchange so they can deposit additional coin types within inside of that space.
Yep, exactly. Yeah, it's a pretty neat concept. Maybe it makes sense to just onboard that directly into the framework.
Yeah, if you could actually share us a link, I'd love to dig into there and see what we can do in that space and maybe collaborate with those individuals to see where we can go with that.
Yeah.
I have a slightly tangential question as well, and that's for anyone who's interested in getting into security. I guess, kind of where was your start from, and how can anyone else kind of who's interested in making sure that both their programs are secure as well as maybe finding bugs and others, how do you recommend them to get into that?
Yeah, so actually, I started out doing bug bounty. So that, like the first audit clients we got were people that we reported, bugs to, and then we asked them if they wanted an audit. So I think that worked pretty well during a bull market. I'm not really sure if it would work well now, but I mean, I think probably the best way is, if you have a track record and if you're able to find these issues, right, then you probably won't have a problem getting hired. And I think in order to find this, you need to dig really deep into the systems that you're looking at, right? So try to understand at a low level what is actually happening. So like read the source code, try to see, you have like, for example, an equals operation, but like what does that equals operation actually look like when it's run by the move VM, right? I mean, like all this stuff is open source. It's you can dig deep into it and you can understand what's actually happening. Like for example, how does the equal operation charge gas, right? Like that might be like a pretty interesting question for someone to figure out. And I think just like having these questions and then digging deep into what is actually happening at the VM level is a really great way to build this intuition. And you'll be able to see things that maybe don't exactly line up, right? Because I think a lot of protocol developers, when they write their code, they don't really fully understand what is happening, right? I mean, for example, protocol developers probably don't read the VM code, right? And I think if you're able to do that, you have kind of this information edge against them, and then they might miss something that you can then notice. Yeah, I think it's just like a lot of reading and understanding.
Just had a brain close there. So now that you're probably one of the most people that are intimately aware of both Move and the Aptos framework, and by that means you're also probably familiar with some of the limitations, or should I say more positively, features that you'd like to see in the space. So what are your top 3 features you'd like to see in Move?
Yeah, so actually I have, I think Move as a language is really great, but I feel like it's also a little bit primitive. So for example, macros, right? That's something that Or I guess the reason for macros is because function calls are pretty expensive, both like at the interpreter level, but also, gas wise, they're pretty expensive. And then one thing that would be really nice would be having some sort of macro way to, like, for example, expand out like a min function, right? You don't really want to pay 1,000 in gas for something that is like a simple compare and return. So I feel like that would be really helpful. I guess another thing might be like enums, right? So just syntactic sugar for a lot of these things. I mean, they're mostly small things, but I think it could help the programming experience a lot. Of course, then you have the.
If I hear you right, Robert, you're basically saying we should avoid of incentivizing people to write bad code just because of saving gas, right?
Yeah, exactly. Actually, yeah, we've had this question come up a lot. People have asked us, hey, should we just inline all our functions into one big function because that will avoid the function call? And then we always tell them, no, you should not prioritize saving gas over ruining your code quality, right? But it's something that people are thinking about. They're considering, putting everything in one big function if it removes function calls. Or private function inlining, for example. Like maybe you could add the inline macro to a private function and automatically inline it. I think that could also work.
The one thing you didn't call out there, Robert, which is really shocking because everybody else asked for dynamic dispatch or interfaces, traits, what have you not. How do you feel about that technology or that's enhancement, if you will, if that came to move? What would be your thoughts on that?
I think it's a tricky
Especially
one.
wearing security hat.
Yeah, I think it's a tricky one. I think dynamic dispatch often opens people up to like a lot of unexpected attack vectors, right? Like if you're calling an arbitrary function or an arbitrary program, arbitrary module, I think most people don't fully reason about what that module can actually be doing, right? Like I think there's very limited use cases where you want to call a truly untrusted module. So I would be kind of wary about, the sort of dynamic dispatch pattern. I also think it's probably very hard to implement in Move, or actually, I don't know if it's. I think it would require a decent amount of refactoring on the VM level. So I think there's like lower hanging fruit that you can do to make people's lives easier.
Don't forget about the power of native functions that can easily do some evil things in that space to enable various types of dispatch. So actually, one of the reasons that has at least come to me in the conversations I've been in is when somebody's making a bridge, oftentimes bridges would prefer to be able to speak naturally to the destination application. However, because of the limited subset, they have to pre-program the bridge with it supports these specific types, and they have to do more of a pub sub model versus just a push model. And so that's kind of the area where it feels like it might be a little bit more sensible. And then the other one that I was kind of noodling on was specialization. So if I have a coin, there might be certain cases where I want to validate a transfer before it's actually done across a coin. Similarly, like with an NFT, if I want to support transferring an NFT, it'd be really great to have some sort of framework in there to say, make sure the attribution or the royalties or whatever is actually being properly enforced and there's not some weird backdoors happening.
Yeah. Actually, I guess another one might be like heterogeneous types. I think that's kind of I guess an often complaint now that I think about it. But yeah, I mean, I think dynamic dispatch has potential downsides that people don't really fully reason about. So always better to. I mean, I'm always going to be on the safe side and always tell. Maybe we should think a bit more about it.
So let me push you a little bit more, especially since you're wearing the security hat, and I've been told I'm a danger. So in terms of. So we have upgradability in Aptos framework, which allows for you to change basically the guts of any function.
Yep.
How different than dynamic dispatch?
I think the concern with dynamic dispatch is if you're calling it with potentially untrusted data, right? So if you have some sort of module, like let's say a Flashman module, right? And then you call, and then the people implementing the Flashman might be like, hey, what if we just call an arbitrary program or arbitrary module with this, right? And then I guess the concern then would be if there's some sort of reentrancy scenario, which I mean, I guess you could just mitigate reentrancy at the VM level. You could say that, you cannot have reentrancy at all, but I think there's just like a lot more things you need to think about in that case, right? I do agree that, if you're just calling only trusted data, it doesn't really make a difference because, you just be upgrading anyways. But if it's any, address module function combination, I think that is a bit more worrying.
So I've got one last question. I'll throw it off to anybody else, and plus we've got audience on Twitch if they have any questions. So one of the things that's come a lot in the conversations I've had with various ecosystem developers is what's the right model for application deployments? And they're specifically talking about the upgradability. Should they be doing immutable, or should they actually allow for compatible upgrades? And what's your thinking on that?
Yeah, I mean, I think people always think that they should make it immutable until something bad happens, and then they realize they should have made it compatible, right? I guess it depends on the complexity of your module, right? I think if it's something very simple, like 100 lines, and it's been audited, I'd probably be pretty confident that there's nothing going to go wrong, and then you can make it immutable if you want. That being said, if you do make it immutable, you should also add flags that would allow you to, disable it in case something horrible happens. But I think I would probably recommend compatible for the general case. And this is with the usual caveats of using a multi-sig for your deployment key. Don't just have a single private key that controls all your deployment. But yeah, I think compatible is probably safer for now because there's always going to be things that you miss the first time around.
Okay, I have one final question then, because you brought up a lot of interesting points there. So what I've heard from a lot of the developers is it seems like they almost have a knee-jerk reaction to go straight to mainnet with their application the first time. And that just, I've gotten into a lot of philosophical conversations, dare I say arguments with my colleagues about here's the right way to do things, which starts with, starting very early on, not even going to a real network, just getting good tests and having your move end-to-end test suite. I'm kind of curious, you've looked a lot at the ecosystem and you probably have your own opinion. So I'm curious, both what have you seen as the traditional path that most of the move engineers are taking? And what would be your preferred approach for folks to actually building new smart contract languages inside the space?
Yeah, I mean, of course, we're always going to recommend more testing, right? Like, I think if people had a month to fully test out their program, we'd be much happier. I think, unfortunately, there's a lot of economic incentives that push people to deploying on mainnet, right? I think for better or for worse, people think that being on mainnet day one is going to be very helpful for their project, which I mean, I think is probably true, right? Being able to say that we were on Aptos day one of mainnet. So I think that's probably the reason why a lot of people are kind of pushing these deployments. And I mean, we always recommend to have more time, but at the same time, we understand that projects have this strong financial need to be on mainnet day one, and they're already crunching timelines. So yeah, I think it's a hard question, right? It's about what the project's risk profile is, how complicated the project is, and then how general firm has tested their code. Yeah.
Cool. Any other questions? All right, well, thank you so much, Robert, for coming to visit us today. I really appreciate it. Shared a lot of really important and interesting things on how to make sure we develop both Aptos and Move in a safe and secure fashion. So again, thank you so much.
Yeah, thanks for having me on. See you guys.
Thanks, Robert.
See you.
All right, so let's take a couple of questions from either Typeform or Twitch.
Yeah, if you have questions, please let us know in Twitch. You can also let us know in the discussions in Discord. We will check all of these.
So one question that came up, and I'm not really sure what to make of it, but was, do you have tutorials for non-developers? And I don't think we have any tutorials for non-developers, but I'm not quite sure what a tutorial for a non-developer would be.
So I would actually say that the Move book is the closest to this because it's really very easy and very basic. And also, as you said, it is a couple of examples which you should run. It's also being translated into Chinese and I think other languages or so. So it may also help. So, but it's definitely not tutorial for a total beginner. So let's say it's a tutorial for a motivated beginner. So that could work if you are motivated enough. Otherwise, you would need to create this.
Yeah. And feel free to write issues on our GitHub repo or the Aptos core GitHub repo. If you have ideas of what type of tutorials you'd like to see for non-devs, we're always eager to increase the size of the ecosystem and those that are contributing to Aptos.
I think there's another way to interpret this question. So I think in blockchain space, there's been a lot of popular about like no code smart contract languages, no code smart contract development. And I think it's something that we, a couple of our team members have started to look into a little bit, but we don't have anything to report at this time. But the idea I think is more visual kind of coding, building blocks that are built up, as opposed to having to kind of get too well up into some of the details. Or maybe those are starting points.
Well, on that end, actually, our NFT standard allows for folks to go and create their own NFT without having to write any code. Obviously, you have to be familiar with the command line interface, so it's still not there yet, but we're making great progress every day.
I wonder also, maybe the question even went also in a different direction. So if someone who is kind of basically running a project based on Move, but is not programming him or herself, what do they need to know about the language without being a developer? So that's an interesting question. And I think probably the closest we have is a white paper, but we could also imagine that there's something better than that for those kind of people which are more in a management or organizational position.
Sure. Yeah. So one of the questions we do have is what are some of the unique advantages of the Move language specifically for NFTs?
For NFT, yes.
You don't want to take this one, Max? You're the one
I
saying
You should take that.
Yeah, I can take this one. Yeah, I think so. I think NFTs are actually a really, really great way. NFTs and coins are a really great way to highlight some of the very special things about Move, and that's you have capability semantics, right? Like on resources specifically. So this means is that you can specify that an NFT you can drop it, for example, which means that you can burn it, and you can also store it, right? Which is what you want. You want to be able to store an NFT in someone's account, and potentially you may want to burn it eventually as well, depending on what you're using the NFT for. The other pieces that we have are, for example, copy. And so the reason that NFT doesn't have copy is because we want them to be non-fungible, right? We don't want to ever copy NFTs accidentally. And so the beauty of Move for this kind of specific application of NFTs is that at the compiler level, it'll enforce all these for you, right? There's no way to accidentally copy because of bad code or some edge condition. It really is, you'd have to go very, very well out of your way to literally clone the NFT by making a new NFT. It'll be a 50, 60 lines of code to do it. And so the compiler guarantees these basic pieces for you, right? And so we have a fairly comprehensive, mildly complex token spec to begin with that allows you to represent both like ERC 721 as well as ERC 1155, fungible and non-fungible tokens with the same standard, but they all kind of fall under this neat umbrella of you can't just let an NFT dangle somewhere, you always have to either store it or burn it by the end of a transaction. And so much safety, wow, I think is the TLDR there. I don't know if anyone wants to add anything to that.
Yeah, it's still in its infancy, and we'd love to get feedback about how we can make the NFTs standard better. We do imagine that we'll have lots of iterations of it over time. Hopefully, we can keep a lot within the V1 standard or whatever current standard we're in to date, and only really do a dramatic upgrade once more pieces land, particularly as the Move language evolves and provides us more functionality that makes it more effective to build different types of NFTs and tokens. So I have another question, and it's kind of like a two-parter. First part is, as you may have noticed, the resource demands for our running a full node, running a validator have gone up. I'm curious if anybody here could potentially talk a little bit about that topic.
Sure, you want to go?
Sure, I think so. The specs on our website, I think it depends on different networks, right? Like for example, if you're running a full node on DevNet, you can still keep the same resource spec or hardware requirement as like before, because we don't see that kinds of crazy volumes or anything that there yet. And then for testnet, we're asked to be a little bit more beefier because we see heavier traffic over there. Again, this is obviously driven by demand, and mainnet, since we don't have a mainnet yet, we're being very paranoid over the specs to launch for day one, right? So we are asking people to over provision a bit to lean towards the safer side, because we don't want the networks to launch on day one and suddenly find out we're super popular, there's really high demand, but people all have to pay really high gas fee to get their transaction through because like the network is saturated or overloaded. Or people could just like spend very small amount of tokens to concentrate or overload the networks for hours, that kinds of stuff. So it is for user experience, and over paranoid over like, we don't know what's the demand. And then hearing so many ecosystem projects are so excited about Aptos and wanted to launch with us for day one. It's very exciting, but also scary at the same time to us because we don't have zero ideas on how much demand there will be from day one. That's why, like for mainnet, we are asking a lot actual on top of the testnet. We beefed up all the machines and asked all the node operators to increase the disk space and beefy up the CPUs and memories. Not because in our testing we haven't we see that it required that much. It's really about like we wanted to be safe on the launch day, that everybody have a good experience.